Hello, student. So I hope you have drawn the sketch. Okay. So I have drawn it for you. Okay. Before that, I will show you the calculation also. Mm, So, these are the design parameters of our coupler. Okay. Coupling factor is 6 dB, and design frequency, that is 3 gigahertz, and this is the transmission line impedance, that is 50 ohm. Okay, so these are the design parameters, and based on these design parameters we can calculate the magnitude of S31, that is coupling factor actually. Okay, so so that we can calculate the uh, low impedance and high impedance, uh, then based on this low impedance and high impedance, and also here we are given the substrate specification. So I am using Meltec NX9320 for my design. Okay, so these are the specification related with Meltec NX9320. Okay, so relative permittivity, it is 3.2, and loss stagnant, and this is the dielectric thickness D, 0.762, and this is the metal thickness 1.8 micrometer. Okay, so based on this substrate specification and these impedances, we have calculated the transmission line width and low impedance line section width and high impedance line section width, and also we have calculated length for low impedance line section and length for high impedance line section, and we take our transmission line section, the transmission line section as 10 millimeter. Okay, 10 millimeter length. Okay, so these are these are the dimension. Okay, so according to dimension, this dimension we are going to design our BLC, branch liner up. Yeah, okay, our BLC. Okay, so so this is the sketch I have drawn. Okay, so I think here if I going to draw this sketch, it is very hard. Okay, because here it is very hard to draw the straight line. Okay, so so I use a piece of paper and draw this sketch. Okay, I think you also can do the same thing. Okay, so you can see that we have already drawn uh, this is our board actually. Okay, so this is the board. Okay, so this is the board, and we have drawn this board. Okay, we have drawn this board. Okay, so we have already drawn this box. Okay, this is our board. Okay, in this board we are going to design our coupler. Okay, so we have drawn this board, and we have drawn the substrate material, and also and also we have drawn the ground plane. Okay, so the length is 336.04 of this board, and the width is 28.6 millimeter. Okay, so these values we have already calculated. Okay, so in this board we are going to design our branch line coupler. Okay, so here we have given 5 millimeter and 5 millimeter gap to do the design. Okay, so here we start the design. Okay, okay, and we have drawn this line section, this box, this rectangle, this section, and we have drawn this section. Okay, then we have extracted this section from this section, so we already draw this part. Okay, this part We have already drawn this part. So that is the branch line coupler. Now we have to add this transmission line. Okay. So to add the transmission line, okay, you can find any appropriate value, appropriate position. Okay. For example, if you are going to draw this transmission line, so this transmission line should be aligned with this line. Okay, with this line. And also this transmission line will align with this line, and this transmission line, this transmission line will align with this line. Okay, and also this one. Okay, so you can find this point. Okay, you can find this point, x value and y value. So for example, here x value is 7.4 because here we have given 5 millimeter gap, and the low impedance transmission line section is 2.4. So we will get 7.4. So this is this point. Okay, and in the same manner you can find this point also. So that is 7.4 plus 13.8, this point. Okay, and also you can find this point and this point. Okay, so this point you can find. Okay, then you can position this what is this rectangle. Then you can give appropriate value in x direction, appropriate length in x direction, and appropriate length in y direction. Then you can draw this transmission line section as we expect. Okay, so that is the normal procedure. Okay, and also if you can also start with here. Okay, if you start with here, you have to give the value again from here in this way. Okay, this direction, and for y you have to give the value in this direction. Okay, so anyway you can draw, you can try to draw this line. Okay, so, and if you want, you can find this point also. If you want, you can find this point also. Okay, what is that point? Okay, so you can see that. So transmission line section 1.8. Okay, so this is 7.4. So if you subtract 7.4, 5.6. Okay, so you get 1.8. Okay, so you get 7.4 minus 1.6. So this point, if I reduce this value, I will get this position now. Okay, so here this value is 7.4. Then I reduce. So this length is 1.8. So I reduce 7.4. I reduce 1.8 from 7.4. So I will get 5.6. Okay. So you already calculated that value. Okay. Okay. So this is 5.6. Okay. So this is 5.6. Okay. Okay. And this position also 5.6 x position. Sorry, y position. And for this point, x position is minus 10. Okay. So if you consider this position, that is the x position is minus 10, and x position is minus 10, and the y position is 5.6. Okay, so if you give that position, and if you have given the appropriate length to this direction, to this x direction, and to this y direction. Okay, so the x direction length is 10 millimeter, no, because we have taken this transmission line as 10 millimeter, and the y direction length is 1.8 millimeter. That is the width of the transmission line. That is 1.8 millimeter. Okay, so likewise we can give as you wish. You can give any value. Okay, it is not compulsory to use this point. You can get any point, and you can draw as you wish. but it should be match with your design. Okay, and also you can here also you can select this as x-axis and this point as y-axis, and also you can do the calculation. Okay, so what you have to do is you have to find the x and y and z coordinate and lengths. Okay, so most probably if you watch YouTube video, you can see that this middle point is selected as the origin point. Okay, so this is x direction, y direction, and this is x axis, and this is z axis. So this will be the 0th point. Okay, but here we are using this point as 0th point. Okay, so you can do it as you wish. Okay, there is no restriction. Okay, so I'm going to do in this way. Okay, okay. So if I go to the, oh shit, what happened? I think I have faced a power cut again. I think our work is not saved. No. Okay, so anyway, I will quickly do that. Okay, so insert HFSS design. Okay, so here we have the value. Okay, and then we have to go the rectangle. Okay, so this is our ground plane. Okay, so I will take the orientation. Okay, I will change the orientation as I wish. Okay, so we use this orientation. No. Okay, this is x y axis and this is x axis and this is z axis. This is z axis. Okay, so I give the, I will change the color of the rectangle. Okay, okay, so I have changed the color. Okay, so I have changed the coordinate. Okay, so I will change the coordinate as in the sketch. Okay, so you can see this is minus 10 and x-axis is y-axis is 0 and the length is 36.04 and 28.6. Okay, so I will give that directly. Okay, so position I will take 1.10 and y position I will give as 0. Okay, and next length, that is 30, is that 36.04, 36.04, and y length, that is 28.6. Okay, so this is the, so I will give the okay. Okay, so this is the ground plane. Okay, then I have to draw the box for the substrate. Okay, so likewise I can draw the box. Okay, then I will change the color. I think we change it to red, no? So I will change it to red. Okay, and and we'll change the coordinate. So it is minus, and the y position should be 0. Z position also should be 0, and x-axis should be 36.04. Y-axis should be 28.6, and z-axis should be 0.762. That is the width, that is the thickness of the dielectric material. Okay, so this is, so we have already given that one. Okay, okay, so you can see that we have uh, our ground plate. Okay, we have our ground plate here, and this is our dielectric material. Okay, so I have given that one. Okay, then I give, okay, so I can change. We have learned that for the solid material, we can change the material. Okay, so we have to change the material. We have to change the material. If you know this edit, okay, then what is our material? Net Meltec, Meltec NX 3.220. No, this one. Our permittivity is 3.2. Okay, so I give it okay, okay, okay. So I have assigned the material. Okay, then I have to draw another rectangle. Okay, so that rectangle is from here to here. Okay, okay. So so I will change the color that one also, that is a copper. Okay, okay, and I have changed the position. Okay, the position is x-axis is 0, y-axis it should be 5 millimeter, because we are given 5 millimeter shift. Okay, we are we have uh, we allow 5 meter gap. Okay, between to the margin of the board. Okay, I think you can remember. So it is 5 millimeter, and this position, the set position also will be 0.762. Okay, so it should be on top of the dielectric material. That is why I put like this. Okay, so this is rectangle. Yes, this one. Okay, so this is 0 and this is 5. Okay, this is 5 millimeter, and this is 0.762 millimeter. So what is the x value? Okay, so length of that is 16.04. Length of that copper plate is, length of that rectangle is 16.04. I think you can remember 16.04. That is x direction, and for y direction that is 18.6. Okay, that is 18.6. Okay, so I have given that one also. So I got this one. Then I have to draw another rectangle in here. Okay, another rectangle here. Okay, to subtract, to make that transmission line section. Okay, so that rectangle is rectangle 3. Okay, so I have given I should given the line. I should given the coordinate. Okay, so so this will be the width of our low impedance line. So it will be 0.64, that is for high impedance. Okay, and this will be 2.4, that is low impedance section. Okay, so it will be 5 plus 2.4, that means 7.4, that is y-axis coordinate, and from here to here it should be 0.64, that is x-axis coordinate. Okay, so I will give that coordinate. Okay, so I will give x-axis as 0.64, that is the width of our high impedance line, and we have to give 5 plus 2.4. 2.4, 5 is the gap and 2.4 is the width of low impedance section. Okay, so so 5 plus 2.4, 7.4, and the z axis should be 0.762. Okay, 762. Yeah. Okay, so what is the x-axis value? Okay, so if you have calculate the inner box, okay, the length is 14.76. 14.76. Okay, you can check the sketch. Okay, and the inner width is 13.8. So these can be calculated very easily. Okay, okay, so this one we have put. Okay, so you can see that. Okay, so you can see that inner length is 14.64, and the inner width is 13.8. So we have put here, we have start to draw the rectangle here. This is a starting point, that is 7.4 and 5 5 plus 7.4, the y dimension, y point, and x point is 0.64. Okay, 64. Okay, so we have already given. Okay, now we have to subtract this rectangle 2. For that one, I control and select. I push control button and select the rectangle 2, and also I will select the rectangle 3. Then you can see that this section is highlighted. So this is the subtract command. So I do the subtraction. Okay, so I have subtract. Then this is our low impedance section, and these are our high impedance section. So this is our branch line couple. Okay, now we have to put the we have to add the transmission line. So I'm going to first add the transmission line section here. Okay, so for that one I also should have a line. Okay, and I should draw like this. Okay, okay, like this. Okay, so this line should be aligned with this line, and this width should be 1.8. Okay, so based on that I already find the position here. Okay, so I will start to draw from here. I will start to draw this rectangle from here. Okay, so what is this position? That is -10, 5.6, this position. Okay, so I take this position, -10, 5.6. Okay, so I get that position, and the length is 10 millimeter. The width is 1.8 millimeter. Okay, so I so I give it is rectangle 4. Okay, so I will change the color to the copper. Okay, we use yellow to show the copper. Okay, and so this is rectangle 4. Okay, so here we have to move, we have to give this one. Okay, okay, so rectangle 4. Okay, and this is the, okay, the position should be minus 10. Okay, and 5.6 minus 10, 5.6, and the Z position should be 0.762. Otherwise, it will be not in the substrate material. Okay, so these are the position, and I have to give the x-axis and y-axis value. So x-axis is 10 millimeter, y-axis is 1.8 millimeter, no, 1.8 millimeter. So if I okay, so you can see that it is nicely fit, nicely aligned with this line, no. Okay, so this is one transmission section. Okay, so this is our port 1. Okay, so I think you can write in somewhere. So this is rectangle 4. This is rectangle 4, that is for port 1. Rectangle 4 is for port 1. Okay, rectangle 4 is for port 1. So I will take another rectangle. Okay, so I can copy this, Control C and Control V. Okay, so it is copied. Okay, so you can see that you have another rectangle. Okay, so I put that rectangle here. It is for port 2. Okay, that is for port 2. Okay, so I put that rectangle 5. Okay, so so I have to change the position. Okay, so I have to shift this to here, no, shift this one to here, actually not this one, the new one, from here to here. So here we have two rectangle. Okay, the original one and copied one. So now we have to shift it from here to here. Okay, so I have to give the appropriate value. Okay, so let's check what are the value we should give. Okay, I think it is better if I can move this from here to here. No, I think it is easy. Okay, so we will draw the port 4. Okay, this one. Okay, so what I have to do is, if I shift this point, so this is the x-axis point, that is 5.6 to here, align with this. If I align with this line, if I move this point to here, so it will shift to here. No, I will show. Okay, so we have drawn this one. Okay, I delete these things. Okay, now you can see that we have drawn this one, this section. Now we have copied it here. Okay, so we have a new one. Okay, now this point is minus 10, 5.6. So this is the x-axis and x point and y point. Okay, so if I move this x point, that is 5.6, sorry, y point 5.6 to here. Okay, so that is this line, no, that is 21.2, 21.2. This is 21.2. So if I shift this 5.6 to 21.2, this transmission line will be shifted to here, and it is perfectly matched, perfectly aligned. Okay, so I will do that one. Okay, so this is rectangle 5. Okay, so I get the position. So the x position I'm not going to change, and I'm going to change only the y position. What is the y position? That is 21.2. 21.2. Okay, correct? So if I, okay, let's see what happened. So you can see that another transmission line, and it is also nicely aligned with this line, no? And it is also 1.8 width and 10 millimeter length. So this is okay. Okay, so that is rectangle 5. Rectangle 5 is for, you can note it down, okay, because it will be important. Rectangle 5 is for port 2. That is for port 2. Okay, rectangle 5 is for port 2. Okay, and uh, and now I will draw this port. Okay, that is port 3 according to our design. Okay, so this will be port 3. So what I have to do actually? Okay, so now we have drawn this one also. We have drawn this part, this transmission line also. Okay, you can see that we have to shift it to here. Okay, and this point will not be changed. This y point will not be changed. We have to shift it in x direction. Okay, so if I change this x value, so here the x value is -10. If I change that x value to here, so what is that position? That is 15.72. No, sorry, not 15.72. 15.72 is this value. Okay, this value. Okay, and it is 16.04. Okay, it is 16.04. Correct. So if I move this point to here, this point to here, okay, so I think we can get that one also. Okay, so let us check. Okay, so so this is rectangle 5. I copy it, Control C, Control V. Then I have another rectangle, okay, with same color and same properties. Okay, so here I change only the x-axis value. X-axis value. So what is the x-axis value? It is plus, no, it is plus value plus 16.04. This value, okay, 16.04. So let put 16.04 here, 16.04. Okay, and see. Okay, you can see that it is also nicely aligned, no, nicely fit. Okay, here it is also nicely fit. And now we have to create this one. We have to draw this port. So how to draw that? So the same way I can move this part. Okay, so I can move this part also here, and you can move this part, this transmission line also here. I will use this one. Okay, so what I have to do is I have to change the y-axis point. Okay, so now I have drawn this one. Okay, I have drawn this one. Okay, drawn this one. So what is the y-axis value here? That is 21.2. 21.2. Okay, so if I move it to, so this is the y point value. Okay, if I move it to here, if I move it to here, okay, so what is this value? The same value, no, that is 5.6. So if I move it to 5.6, I think this will be nicely come to here. Okay, so I will do. Okay, so I double click. Okay, so I'm not going to change the X position. Okay. And I'm going to change the Y position. The Y position should be 5.6. No, 5.6. Okay. So 5.6. Okay. Sorry, we didn't copy it. No. So anyway, now this is rectangle 6. Now it is here. Okay. So we will copy this one, Control C and Control V. Okay. Now we have to move this to here. Okay. So again, we have to change the y-axis. Okay. So y-axis. So here y-axis is 20.21.2. No. Okay. So I think you can remember. So if you can double click here, and if you change the y point 21.2, I think, don't get confused. Okay. Mistakenly, I didn't copy this, and without copying, I have move this to here. Then I have to again copy this one and move to here. So this is our branch line coupler. Okay. So you can see that there are 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 3, 4, 5 transmission line available. So we have to collocate them. Okay. To collocate them, you can select them. Okay. You can select all the micro strip line. Okay. So there are 5 lines we have selected. Then we have to unite them. Okay. We have to unite them. So you can see that now nicely our BLC coupler is created. Okay. Now we have our BLC coupler. So now what we have to do? Okay, we will see it.